Okay, today's lesson will be exponents, more specifically integers as exponents. So to warm you up, we want to expand 6 to the 4th times 6 to the 7th, which is really 6 times 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 6, which is 6 to the 11th. In other words, we could have done a shortcut by just saying 6 to the 4 plus 7, which is 4 plus 7 is 11, so we add the powers. Over here we have 3 to the 4th to the 3rd power, which is 3 to the 4th times 3 to the 4th times 3 to the 4th, which is 3 to the 12th. The shortcut here would have been to multiply the powers, distribute the powers. 3 times 4 is 12. Right here was 6 to the 4th plus 7 to get 11. 5 to the 8th divided by 5 to the 4th, well, that's really 5 written down 8 times in the numerator, 5 to the 4th written down 4 times, right, 4 times in the denominator, and we cancel each one of these out. And that gives us the result of 5 to the 4th power. Now, the last one, power of the quotient, 4 sevenths to the 5th power is 4 sevenths times 4 sevenths times 4 sevenths times 4 sevenths times 4 sevenths, which is 4 to the 5th power times, 4 to the 5th power over 7 to the 5th power, which really means you are distributing the power to the invisible first powers down here. So the anatomy of an exponent is that the base is the larger number and the smaller number up in the superscript is the exponent. Okay? We already know that it's repeated multiplication, 3 times 3 times 3 times 3 times 3, which is 729. Anything to the 0 power is always 1. Any number raised to a power of 0 simplifies to 1. And finally, 2 to the negative 3rd power. Before I tell you what the equivalent expression is, I want to give you an example. If we have 2 to the 2nd power over 2 to the 5th power, based on the warm-up, we know that we can just take the powers and subtract them. We end up with 2 to the negative 3rd power. Right? Well, let's take this example again, this expression. Let's expand it out. 2 times 2 over 2 times 2 times 2 times 2. Cancel these out. That leaves 1 over 2 to the 3rd power. So, as you can see, these are equivalent expressions. In other words, 2 to the negative 3rd power is simply the reciprocal of the same exponent but negated power. So 2 to the negative 3rd power is 1 over 2 to the 3rd power. Flip the negative exponents to the other side of the fraction bar, then make the exponent positive. So the properties that are highlighted here are all the ones that we're going to emphasize today. The other ones you've had before in Algebra 1. So these are the big ones we're going to practice today. Example 1. We need to use order of operations, and we'll simplify inside the parentheses first. 4 squared is 16. 8 to the negative 1st power, like we said, you want to reciprocate it, so we'll put a 1 under it, and we'll take this negative power with the base, and we'll reciprocate it and make the negative power positive. So now we have 16 to the 0, which is really just 1, and 1 times 1 over 8 is just 1/8. Example 2. Write this expression without a denominator. Well, the first part is easy. 4 over 2 simplifies to just 2 over 1. The denominators here we can circle them and bring them up to the numerator under the condition that you have to negate the power. So these are positive powers, and when we move into the other side of the fraction bar, they actually become negative. So we can achieve this by negating these two exponents down here. As you can see, they're now up in the numerator, and they are both negative. The x to the third remains x to the third, and 4 over 2 we reduce down to 2 over 1. Notice that x cubed times x to the negative fifth, we just add these powers to get x to the negative second power. Finally, this is our answer. 2 times x to the negative second power times y to the negative second power. 4 times 4 to the 0 power, well, order of operations says to do exponents first, so 4 to the 0 power is 1. That 4 remains. And down here we want to actually bring the 2 to the negative second power up to the top. And the reason why we want to do that is because whenever you evaluate or you simplify an expression with negative exponents, you must make them all positive. So we want to bring this up to the top, to the numerator. We end up with 4 times 2 squared over 2, which is really 4 times 4 over 2, which is 16 over 2, which is 8. Let's simplify this one. We have 2x in parentheses to the negative third power times 2x to the negative third power. Now the big difference is that this power only pertains to the x. This power here pertains to 2 and the x. As you can see, we will distribute that power to the invisible first powers. It's very important to write the invisible first powers, so that when you do distribute, we end up with 2 to the negative third and x to the negative third times 2 times x to the negative third power. Now I put a 1 under these to make them fractions, so that when we reciprocate, you can see we bring it to the other side of the fraction bar, and we end up with a positive exponent. So now we end up with this expression. It's basically 4 fractions multiplying each other. Let's multiply all the numerators together. 1 times 1 times 2 times 1 is 2. And 2 cubed, which is really 8, times x cubed is x to the 6th power, so it's 8x to the 6th power. And 2 over 8x to the 6th power is 1 over 4x to the 6th power. Okay, now order of operations says to work on the parentheses first, so we'll simplify inside the parentheses first before we even deal with the negative 2 on the outside of the parentheses. So first thing, we want to take the negative exponents and bring them to the other side of the fraction bar. As you can see, we brought the y to the negative fourth down here to y to the positive fourth, and x to the negative third in the denominator is now in the numerator as x to the positive third. 6 over 2 reduced to 3 over 1. Now let's go ahead and consolidate. X squared, x cubed is really just x to the fifth, and y squared, y to the fourth is really y to the sixth. And now we have the inside parentheses part as simplified as we can. So now let's handle the negative 2 power outside the parentheses. If you remember, we must distribute to each of the powers inside the parentheses. That means you need to write in the invisible 1 power of the 3. Once you distribute these, you end up with 3 to the negative 2nd power, x to the negative 10th power, all over y to the negative 12th power. You should remember, because we're dealing with all negative exponents, in order to simplify, we need all of these powers to be positive, which means we need to bring them to the other side of the fraction bar. So I circle them and I draw arrows to where they need to go. Final answer, y 12th over 3 squared, x to the 10th, and that 3 squared can be simplified to a 9. So here's your final answer, and that sums up the lesson. Good luck to you.